Okay, let's do our last video. And so I need to look at canisters dropped from a helicopter. So we've got our little helicopter. Let's see, I need to get my pen ready. So we've got our helicopter. So it looks like this. Doot, doot. This. It looks like this. Oh, no. Let's see. It kind of looks like this. And it's got a rotor up here. And see, you can spend a lot of time making your pictures look awesome. So there's a little helicopter type thing that we got. Yeah, it's not awesome, but just go with it. So there's my helicopter. And we drop a canister. And if you drop that canister, say when we're dropping it, I guess it might fall this way. So there's our canister. So this canister is falling. Okay. It's dropped. Originally, it is 500 meters off the ground. So let's say that it falls. It's originally 500 meters off the ground. So 500 meters is originally where it's dropped from towards the ground. So I guess that would be our initial position is 500 meters. Then we know the parachute doesn't open, but the canister has been designed to withstand the impact velocity of 400 meters per second. Interesting. So if we do that, let's see, will it burst? Oh, okay. So notice what they're saying. So they're saying that when it hits the ground, it has to be less than 100 meters per second. So if this is our initial position, we know a couple other things. Acceleration due to gravity is negative 9.8 meters per second squared. So if that's true, then don't forget that's the second derivative. So if I take one derivative, I'm at velocity, and I get negative 9.8 t plus some constant c. But remember, it was dropped, not thrown straight down, so the initial velocity is 0. And if the initial velocity is 0, that means you get out 0 when you plug in 0 in for time. So we get that c is equal to 0, but we knew that because that c is just initial velocity. So if our velocity function is negative 9.8 t, then we can go from that first derivative back to position by taking one more antiderivative. We get this t squared over 2 plus some constant d. But we know at time 0, we should get out 500 meters. So 500 is equal to, okay, so let me see, just double checking, going through here. Negative 4.9, I got my negative 4.9 t squared. If my position, what is it, Eleanor? Plus d is equal to my position. Well, then when you put in 0, you better get out 500. So I plug in 0, I get 500. That means the d is 500, which again, if we look at these formulas for long enough, we realize that that constant, again, is always going to be initial position. So it's going to be plus 500. Okay? So that's what we end up getting. So let's see. Okay. So now what do we want? We want to know when will it hit the ground. So that's when position is equal to 0. So we get negative 4.9 t squared plus 500 is 0. Equal to 0. And so you get that 4.9 t squared equal to 500. It's going to be more than 100, right? I mean, more than 10, excuse me. it's going to end up being 10.1. So when we do this, we get 500 divided by 4.9. We take the square root, we get plus or minus 500 divided by 4.9, which is what? Again, we said that was approximately 10.1 seconds, right? So now what we want to know is, will it explode? Well, what we're really trying to find is the velocity at 10.1 seconds, which is approximately negative 98.99. And since 98.99 is less than 100, it will not burst. It will not break. Because they told us that it breaks at 100. But we found out the velocity was that many meters per second. Okay. All right, last one. Number 19. If you've got a ball thrown up from a roof, so here's this, you put your hand out here and you throw the ball straight up with an initial velocity of 19.6 meters per second because it's going up. The roof, or the initial position is 24.5 meters high. He wants us to find velocity. So let's find V. We also know, sorry, that's a reminder to do something, which I already did. So one other thing that we know, besides everything that we have so far, we also know that acceleration due to gravity is negative 9.8 meters per second squared. So if we go back to velocity, we're going to get negative 9.8 t plus some constant. But that constant is our initial velocity. You can see that by plugging in. You say, but V naught is equal to 19.6 means that 19.6 must be equal to negative 0.8 times 0 plus c. So that constant is just 19.6. So thus, the velocity is negative 9.8 t plus 19.8. Okay, so let me do this. 19.6, excuse me. 19.6. I'm going to take this, move it over just a little bit, go this way, and say 19.6. So that's velocity. But then I take another, so that was one antiderivative that we took. So we took one antiderivative. Now to get back to position, I'm going to take another antiderivative. And I'm going to get negative 9.8. I pull out that constant. The antiderivative t is t squared over 2 plus 19.6. That's a constant, but if we take the antiderivative of a constant, we get a linear. So it's t, and then plus d is in donut. So it's negative 9.8. If you divide that by 2, it's negative 4.9 t squared plus 19.6t plus our d, but the initial position was 24.5, but initial position 24.5 means you get out 24.5 when you put in 0 for time into position. So that means d is 24.5, again, which if you work with these long enough, it's pretty clear that that constant you get when you work backward from velocity, that constant is always going to be your initial position, which is 24.5. So that's my initial position. Awesome. Okay, so highest point is at 2. So if the highest point is at 2, how do we know that the highest point is at 2 seconds? So let's see. How long does it take the ball to reach its highest point? Highest point is S of 2. Oh, it's where the velocity equals 0. So B, highest point. So highest point implies derivative equals 0. In this case, that's velocity equals 0. So that's negative 9.8 t plus 19.6 equals 0. When you solve that, you get t is equal to 2 seconds. We already did part C to find the position. What is the highest point? So that's part C. And then part D, if we take that 2 and plug it into position, S of 2 is going to end up giving you negative 4.9 times 2 squared plus 19.6 times 2 plus 24.5. That's going to give you 44.1 meters is the highest it ever goes. So when will it hit the ground? Well, that's when position equals 0. So I take my position function, which is negative 4.9 t squared plus 19.6 t plus 24.5, and I set it equal to 0. Well, first off, you can take out a negative 4.9. You're going to get t squared minus 4t minus 5. But then that's wonderful because this factors into t minus 5 and t plus 1. So you get t equals 5 or t equals negative 1, but in terms of seconds, negative 1 makes no sense. So t equals 5 seconds is when it hits the ground. What's its velocity when it hits the ground? Well, that's just v of 5. And so if you plug that into your velocity function, I think you'll see pretty quickly that you get negative 29.4 meters per second. So great work, good luck, and I'll talk to you soon.